Hello friends, welcome to another educational video in the field of electricity. In this video we are going to provide all the necessary training about three-phase and single-phase electric motors. In this video I am going to teach you star and delta connections in three-phase electric motors. This tutorial is very useful and all electricians should know it. Please stay with me. Each three-phase electric motor contains 3 coils. Each coil has 2 heads, so there are 6 heads for 3 coils, which you can see in the picture. The beginning and end of the wire of the first coil are named U1 and U2. For the second coil it's V1 and V2, and for the third coil it's W1 and W2. Three-phase electric motors can be terminated by 2 methods. The first step is the star connection. In this method, we connect the end of the all coils together. For this, we use a metal blade and connect them in this way. Now, to start the electric motor, we connect the three-phase electricity to the other 3 ends. If these 3 coils are inside the electric motor and the star connection is made, the coils are connected in this way. And now three-phase electricity is connected to these. In this case, there is a 0 point between the connection point, which means that this point has the role of neutral, and therefore the voltage between the 2 ends of the coil will be 220 volts. The second method is the delta connection. In this method, the beginning and the end of the coil are connected one after the other. For this, the metal blades should be placed in this way. And to start the electric motor, we connect the three-phase electricity to these parts. This connection is done in the coils like this. And three-phase electricity are connected to these points, as you can see in the picture. In this case, the voltage between the coils is equal to the three-phase electricity voltage, which is 380 volts. So the power of the motor in delta connection is more than in the star connection. Section 2. In this section, we want to teach you the method of left rounding and right rounding of three-phase motor. This wire is wired in a star pattern, and we are going to connect three-phase to it. The connection of 3 phases will be like this. With this work, the motor is running. Now, in order to reverse its rotation, it's enough to change 2 phases. To reverse round, we can move two phases of the motor as desired. This section is finished. In this video, we teach a method of testing a three-phase electric motor with a multimeter. This is a suitable method for testing the health of the coil of three-phase electric motor and can give us the result to a large extent. Please be with me. In this video, we perform three types of tests. 1. Continuity test. 2. Short circuit test. And 3. Body connection or current leakage test. Each three-phase electric motor has 3 coils, each of which has 2 heads. So there are 6 heads for 3 coils, as you can see in the figure. The 2 ends of the first coil are U1 and U2. The 2 ends of the second coil are V1 and V2. And the 2 ends of the third coil are labeled W1 and W2. The first test is the continuity test. In order for electric motor to be healthy, the beginning and the end of each coil must be connected and there should be no resistance between them. For this purpose, we put the multimeter on the beep mode and test the beginning and end of each coil. The first coil is healthy. The second coil is healthy. And the third coil is healthy. The second test is the short circuit test. That is, none of the coils should be connected. You can see that none of the coils have a short circuit, so they are healthy. The third test is the connection test to the body. This means that none of the coils should be connected to the body, because this case current leakage from the coils to the electric motor body. The entire electric motor was fully tested, and the electric motor is completely healthy. Therefore, all of coils is healthy. In this video, I want to teach how to turn on a three-phase electric motor with single-phase electricity. There is a very practical method and it's very useful for places where there is no three-phase electricity and also for testing three-phase electric motors. In this video, we turn on this three-phase motor by using this electric plug, one of which contains the phase wire and one of which contains the neutral wire. The first mode is the mode where the motor is wired in the triangle shape. We need a capacitor to start the electric motor. For each kilowatt, a capacitor equal to 70 microfarad is required. For running electric motor, we act like this. Now, if the plug is connected to the electricity, the engine starts to rotate. And to reverse the rotation, it's enough to move the two ends of the capacitor. For star connected motors, we do this. If the plug is connected to the electricity, the motor starts to rotate. Pay attention that for starting three-phase motors with single-phase electricity, the power of the motor must be less than 4 kilowatts. And you should know the rotation speed and power of the motor with single-phase electricity is much lower than normal. In this video we are going to learn how to wire a single-phase electric motor, and we have a wiring diagram. If you want to remember the complete connections of the single-phase electric motor as well as the capacitor connections, we suggest you watch the video until the end. To run a single-phase electric motor, you should know that all of them have 3 wires that come out of electric motor, and you can see them in the picture. Look closely at this map to understand why these 3 wires exist. Each single-phase electric motor contains 2 coils. One is the main coil and the other is the auxiliary coil. The resistance of the main coil is omega 1 and the resistance of the auxiliary coil is omega 2. From the common points of the 2 coils, which is called the com base, and also from the 2 ends of the coils, a wire come out, which is a total of 3 wires. So these 3 wires are the same wires that come out of the electric motor, and you can see them. In order to find out which coil each wire belongs to, we first put the multimeter on the resistance mode and measure the resistance between all of the wires and remember them along with the color of the wires. First, we measure the resistance between black and red and write it down along with its colors. And then we measure red and white. And finally, we measure black and white and write it down. Now, in order to understand which wire is for which coil, we do this. The lowest resistance is for the main coil. After that, it's for the auxiliary coil. And the highest number is for the sum of the two coils. That is, it's related to number 1 and 3. If we pay close attention, the sum of the resistance of the main and auxiliary coils is equal to the resistance between point 1 and 3. So the measurements is correct and the numbers are meaningful because the coils are connected in series. Now, to understand the common base, we note the common color between the main and auxiliary coils, which is the same color, which is the black wire here. Therefore, the red wire corresponds to the main coil, the white wire corresponds to the auxiliary coil, and the black wire is the common base between the two coils. Now we teach the wiring method. For that, we place a capacitor between the base 1 and 3, means between the red and white wires in parallel, and we connect the phase and neutral wire to the main coil and the common base. Now we will wire the electric motor according to this diagram. We connect the capacitor to red and white. And then we connect the phase wire to the red and the neutral wire to the black. By connecting phase and neutral wire, the motor starts to rotate. In this video, we are going to calculate the current of electrical appliance based on their power. Power is usually written in watts, kilowatts, or horsepower, and we want to know each of these, how are they converted into electric current. Before that, we must know two conversions. Each kilowatt is equal to 1000 watts, and each horsepower is equal to 746 watts. For example, 2.5 horsepower equals 1860 watts, or 1.86 kilowatts. Now we want to know how to get the current of the consumer from its power. The working method is different for three-phase and single-phase consumers. First, we will check the current calculation method in single-phase consumers. In single-phase consumers, the electric current is equal to the consumer's power, which is written in watts, divided by the consumer's voltage, which is written in volts. For example, for a 100-watt consumer that works with 220 volts, the current is calculated as follows. Now we get the method of calculating the current in three-phase consumers. In three-phase consumers, the electric current is equals to the power of the consumer, which is written in watts, divided by the radical of 3 cross voltage cross cosinus phi. Radical 3 is almost equal to 1.7. Cosinus phi is a factor of the consumer, which value is written on each consumer, which varies between 0 and 1. For example, for a three-phase consumer, which power is equals to 2.5 horsepower and works with 380 volts and its cosinus phi is equals to 0.8, it's calculated as follows. Note that the current must be converted to watts. The current equals to 3.6 amperes. This video is finished. If you like the video, please press the like and subscribe button. Goodbye.